Hello and welcome to the show. It's me, John Park, and it's time for John Park's Workshop. Here we are. We're ready to go. And hello, everyone over in the YouTube chat. I see Noe and Pedro have joined us. Hey, guys. Also, Marie Meyer, Dave Odessa, Anthony Becerra, Martin Kolinak, Larry Beatty. Welcome, one and all. And, of course, we've got plenty of people over here in the Discord chat. If you're wondering where some of these people are chatting and you're over on Twitch or some other place where there's a seeming ghost town of chat or lack thereof, head to the Discord. It's adafruit.it/Discord. You'll get an instant invite, and you'll want to head over to the live broadcast chat channel, and that's where all these good folks are, such as Andy Calloway, Mr. Certainly, OK, you're on, C. Grover, Jim Hendrickson, hello, and Mr. Certainly, did I mention that? Yes, welcome. Darth Vader, Lars, all the good people. And I think we should get going. So let's see, first of all, what's what? By popular demand, people really liked the teardown of last week's Halloween animatronic eyeball doorbell, and so I'm going to go ahead and do the hacking of said doorbell. So we looked at how it works. Now we'll go ahead and start connecting it up to our own microcontroller and driver boards so that we can make it do what we want, make it play the sounds that we want. Should be a lot of fun. I'm looking forward to that. We'll also do a little bit of exploration of how to figure out what is actually in there, what motors you need to drive, and therefore what kind of hardware you need. Those kinds of things. We'll learn a lot along the way and have fun, I hope. Let's see, what else is up? I'm going to get a sip of water. That's something. And let's see. I think that's all the preamble. So let's get into it. First of all, I want to mention that we've got some Adafruit things to check out. First of all, always important to remind you to check out our jobs board if you're looking for work. If you are looking to hire someone, you can head to jobs.adafruit.com. And if you head over to the jobs site, you'll see that we've got a bunch of positions that are posted there. It doesn't cost anything to use it. It doesn't cost anything to post. And you can also post your own info. If you click at the top, there's either search jobs or available for hire. And there you can see a bunch of people available for hire, including 3D and CAD, -Anjay, quote, bracket, double quote, bracket, in the United States. I don't know what that's about, and I'm scared to click on it. But most of the other ones don't look too scary, so maybe check those ones out. Not sure what's happening there, really. And that's the jobs board, so head on over to jobs.adafruit.com if you want to learn more. Let's see. Also, I want to mention, if you head to the Adabox site, you can go to adabox.com. That'll get you there. We are now making a shift to talking about these in terms of seasons. It's a little broader scope than particular holidays that they might have been, or dates that they might have been built around before. So seasonal, we have a winter Adabox coming up. So if you're interested in subscribing, you can head to adabox.com. You can also get a subscription for someone else as a gift if you'd like. And that is going to be coming out sometime in the winter. So that's as specific as we can get right now. At the top here it says actually January/February 2022 is when this should be shipping. And this is going to be Adabox number 21, the 21st of these that we've done. Wow. Boy howdy. And should be a good one, should be fun. I don't know yet what the theme is exactly. I know what we're planning as far as what's in the box, but as far as theming of it, there's some mystery surrounding that right now, coming from Mr. Lady Ada and Lady Ada, and they won't tell me. So, but I gotta get my costumes and stuff together, right? Let's see, what else is up? The product show I do on Tuesdays. Have you heard of this? This is called JP's Product Pick of the Week. Every week I pick something from our catalog, our massive catalog of cool items, and I show it off. I demo it. I show you how it works, software to code it, hardware to hook it up. And there is usually a massive discount available during the show. You don't need to do anything special other than buy it during the show. So there's not a coupon code that you need to worry about, no puzzles to solve, no secret links to discern, no steganography. You don't have to figure out secret codes inside of a numbers station. None of that. It's just buy it right then while the show is happening, and you'll get a discount. It's often an astonishing 50% off. This week it was the 3-pack of the PermaProto full-size PCB breadboards, and I've done a little bit of a recap, so check this out. The PermaProto full-sized breadboards. These are perf boards in the shape and, more importantly, design of a breadboard. These are real nice, high-quality PCBs that you can use to transfer your circuits from a typical breadboard, where you press your components into a much more permanent home by soldering it into this guy, the PermaProto. These come in different sizes, but this is a really nice one if you're building a project that has a sort of luxurious amount of room on it for input. If you have a smaller microcontroller, you can get quite a few buttons and switches and encoders on there. And that is how I like to use these. It is the PermaProto full-sized PCB for making your projects a little more permanent. Boy, I was so hopeful and optimistic back then, back on Tuesday, that it was going to get fall-like and cooler out. And now you can see me in t-shirts again. I had a flannel shirt and everything. I was so excited, and now it's hot. But actually, that segues a little bit into the conversation about the seasons. Mike P. asks over in Discord if this is still going to be 4 times a year. And yes, the AdaBox is still quarterly. We're just calling the theming around it season-based. So there'll be 4 a year: winter, summer, spring, fall, which Mr. Certainly says is the North American 4 seasons. Sure. And Steve Okayaran asks, can I get those in low-quality PCBs instead? I bet you can, but not at Adafruit. We refuse to sell you the low-quality PCBs here at Adafruit. All right. Yeah, and all joking aside, one thing that you'll find with the higher quality PCBs, by the way, someone had asked the other day about cutting them in half, and I found one that I had cut in half. I can't remember what I was using half of one of these for. But with the higher quality, you get pads that don't lift off if you ever need to desolder them, or even while you're soldering them. So these are very nice quality. And I've never seen them corrode or do anything weird. I think these are probably gold-plated traces, so nice high quality. All right, what else have we got going on? Hey, this is a good time to do the CircuitPython Parsec. All right, let me get that set up right there. Okay, so this is a nice back to basics one right here today for the CircuitPython Parsec. What I wanted to show is how you can use the Adafruit waveform. Let me say that again. I want to show you how you can use the Adafruit waveform library to import a sine wave and use that to generate a tone that you can hear. So what you'll see in my downshooter here is I have a Circuit Playground Bluefruit connected to our little stemma amplifier and speaker breakout. And when I press the 2 buttons, I'm going to play different tones. So these are nice, smooth sine waveforms, and the way that those are created is with this code. I import the board for the pin definitions, digital I/O so I can use the buttons, debouncer to make the buttons even friendlier to use, and then I'm importing audio cores, raw sample, and audio PWM I/O so that I can output over that audio output pin, and then I'm importing Adafruit waveforms sine. Then I am setting up 2 sine waves. I have sine wave low, which is created with this sine wave and then a sample rate of 8,000 and a pitch or frequency of 440. Then I take that sine wave that gets created and I essentially turn it into a table or an array. And that's what this raw sample does. Raw sample takes that array and turns it, or takes that waveform, turns it into a sample array. And then I'm doing the same sort of thing again, except this time with a higher pitch, 660. So this is equivalent of an A and an E. Then I set up the audio output on the board's audio out pin. Sometimes that's A0. On this board, it's just called audio. Then I set up my buttons, and then in the main loop, when I press a button, it does this: audio play, sine wave low sample, and then it loops that. So this is essentially a single waveform, and it just keeps looping that over and over again, so it plays constantly. And then when I do that with the high sample, we get the higher pitch. And so that is how you can use Adafruit waveform to import a sine wave and play it back as a tone inside of CircuitPython. And that is your CircuitPython Parsec. Let's see, let me check. I saw some questions and activity over in the chat there. Why are all the pins on the screen connected to ground rail, asks Adam Bryant. Which screen are we talking about? I'm not sure. If you can clarify, we'll try to answer that. All the pins on the screen connected to the ground rail. I don't know. What did I show? Now I don't know. Are you talking about this little guy here? This? Probably not. It's a mystery. All right, well, if you get this message, please respond, and I'll try to figure out what the question is. And by the way, with that waveform library, there's also a square wave in it. And I'd love to lobby to get a sawtooth and a triangle and some other waveforms put in there, which are useful for sound things, of course, but also stuff like making LEDs fade up and down or blink on and off using the square wave. A pulse wave would be cool. But since we don't want to compute those in real time, we're actually just taking those and using that raw sample to generate kind of a little table, a little lookup table of values that we can play back, which is pretty cool. So it becomes a sample, in essence. Adam asks here, too, why were all the pins on the screen connected to ground? Was it the cut PCB? Could be. The video of you in the plain shirt. Was that during the CircuitPython Parsec? It might have been. Now I don't remember. I don't have a quick, easy way to review that. Now I'm dying to know. Let's see. I don't think I can play this without it playing its audio. I'll have to go back and, yeah, something I did in the, well, here's the permaproto. Okay, so, oh, I know. You're talking about the display. Okay, that was something I explained in the larger show. I didn't actually connect the screen to the ground plane. I actually am using the stemma QT cable for this connection, so it's an I2C connection. But I just wanted to essentially bolt this screen onto here mechanically. If I put it somewhere where it just wasn't going to use any pins, it was kind of off-center. So I created a whole bunch of confusion for everyone by using a couple of these right-angle headers, which allows me to slide that screen into some header pins that look like they're connected to ground, but they're actually not. So it's a big fake out. So sorry about that. I could have just, and probably should have just plugged it in down there and maybe really wired it, but I didn't feel like it, or left it alone, but instead I got a little fancy and hooked it on there. And these, by the way, I didn't drill holes through for these nylon fasteners. They're just acting essentially as feet so that this thing doesn't tilt at an angle. Phew! Mystery solved, I hope. The other way to deal with that, by the way, is to cut traces. So if you do need to use something like that where those traces are connected, you can score with a hobby knife between them and remove that connection and then plug into them and use it just as a mechanical connection to solder to. Thank you for asking, Adam. That was a very good question, and maybe I got a little fancy for my own good and confused things. All right, so let's see. Next up, oh, lovely A72 says, make a Commodore SID simulator with the Adafruit waveform. That would be cool. There are a couple of SID-based synthesizers that I've seen that just use that chip and allow you to play the synthesis on that chip without having a full Commodore 64, which is kind of cool. All right, let's see. Next up, so let's get into this. I'm going to head back to my browser window here for a second, and let's talk about this doorbell a little bit. So this is what I'm working with. This is a little $15 doorbell. You can get them all over the place, anywhere from Halloween stores to hardware stores, big box stores, probably Target, Amazon. They're available all over the place. And this company called Gemmy, they make a lot of motor, sound, animatronic types of things for holidays in particular. They also do a lot of the, I found out last week from someone on our chat, some of the best lawn inflatable types of animatronic things, giant spiders that sit up on your roof and stuff like that. I think they maybe even have done some of the stuff that uses versions of the Halloween mask. What's the mask called? I'm forgetting now, but our digital eyes. Do I have one around? What's it called? Monster Mask, that's it. Some of those, I've seen at least one werewolf that uses the Monster Mask, which is pretty cool, or a version of that, TFT eyeballs. So last week I took this apart and we looked at how it works, and I was actually surprised to see that I didn't find any teardowns online. People collect these, and this fandom wiki page goes through the history of them and where you can buy them, which versions exist, what phrases are on them. And the one I have does these four: enter at your own risk, welcome, good evening, and you rang. I think those are the ones that are on mine. One thing that's popular among people of the internet who are fans of these is to rip the sound from them. So they'll either get a microphone or, even better, create a sort of line in by soldering to the speaker output and then going through a audio interface into their computer, and they'll make high quality recordings of the sounds. So I wanted to try taking this set of phrases, which are on the Spider, which is not the version I have, and be able to play those on mine, as well as control the timing of the eyelid and eye motion, maybe change the eye motion myself. So this is sort of the answer to the question, why would you want to connect your own microcontroller? There's a perfectly good one already in there that does everything, but for the sake of customization, modification, understanding how it works, it's all a lot of fun to go in there and figure out what makes this thing tick and how to drive it yourself. So the first thing we'll do is actually take a look at determining what is actually in one of these, so you know sort of the specifications that you need to be able to handle when you're going to drive it yourself. So let's head over to the workbench, and I will start off by exploring the motors here and figuring out what their specifications are. And before I do that, I'm going to get my chat up so that I can see you there. Hello. So since I have this set up right now, the first thing I'm going to do is actually check the current of the motors. But before I do that, let's zoom in here on the motors a bit. Try to focus on them. And if you're not experienced with these, the first question is just what kind of motors are we dealing with? And the options for motors in electronics tend to be three kinds typically for spinning motors. So there's going to be simple DC motors, either brushless, generally brushless DC motors, servo motors, which are a little more expensive but can be controlled to go to specific angles, and then stepper motors, which are even more complicated to control, so more expensive, can go to very precise positions, and you will not find those in toys. You're not super likely to find servo motors in toys unless they're remote control things generally. So 9 times out of 10, if you open up an inexpensive gizmo like this, you're going to find DC motors. Other clues that we have DC motors are going to be just the general shape. So I don't have any out. Let me see if I have one I can grab from somewhere else. But just learning to identify what these motors look like is helpful. Do I have any? No, I don't have any readily available. So, but this metal flatted cylinder type of shape with a plastic end, very typically the DC motor. This one's blue. You usually see them in this white, the plastic part. And then another clue is this capacitor here. You will often see a, let me get something to point with. You'll often see a little sort of beige colored disc soldered between two terminals, which help to deal with a lot of the noise that comes off of these motors so we don't interfere with the electronics on the microcontroller itself. The other things that we have to look at, okay, what's the power supply that's driving this? What's the voltage of that? And then we also have, in the case of this one, an LED to consider and a speaker. We have audio on here, and we have a little speaker built into the back lid. So the first clue for us in figuring out what we're going to be, where our requirements for driving this thing are just going to be the voltage that is supplied by the batteries. So this is 3 batteries, 3 alkaline AAA batteries are what came in the toy, and that's what we'll start with there. If you need to replace your batteries, this is what you're going to be looking at. It's these guys right here. And these are actually the ones that came with. So these start off life at a nominally at 1.5 volts. So that's going to be 4.5 volts of DC that drive this thing. So the somewhat reasonable thing to guess at first with toys like this is if they aren't doing anything terribly fancy with boost converters and buck converters, is that probably these motors can handle something close to just that straight up battery voltage. And it's pretty common for these to be able to handle anywhere from maybe 3 volts at the low end, 3-4 volts at the low end, and they'll still turn up to 9 or 12 volts. But in this case, I'm just going to guess that something around 4.5-5 volts will be safe to drive those with. The next thing we can do after guessing is to check the voltage. But just because I have things set up for this and I don't want to reset it up, before I do that, let's just check the current draw. So the way that I'm doing this is, first of all, I took a picture of this board here before I started pulling the connectors off. And one thing that we saw last week that I thought was great is that this board connects to almost all the peripherals using 2-pin JST XH connectors, which are pretty much the same connectors that you find in our battery packs. If you look at the battery pack for our LED glasses, same type of connector there, or similar type of connector. Actually, these are PH size, and these are XH size. But the JST connector is a pretty common one. Adafruit happens to have some things that make it handy for dealing with this. One thing that I had laying around was a kit of JST XH connectors. So that's the exact connector here. Here's a spare one of them, so those are kind of useful for interfacing. Especially if you're going to make a circuit board and you want to lay down, maybe use one of our PermaProtos and lay down some connectors that you can plug stuff into. And we also have, I don't have any right here that are the ones we sell, so I made some of my own. We have in the store some little pigtails that are in different numbers. So these are the 2-pin JST-XH. So what I've made here is essentially something that I could plug one of these motors into, and then I have bare wires on the end that I can plug into whatever I've got driving it, or we can terminate that in other things. I'm going to use screw terminals, but I've got one case where I did some little pins on the end of it. So this gives me a connector that allows me to hook up all these peripherals to my own microcontroller and avoid the board there. So looking now at the layout of things, the eyelid motor, so that's this motor here, when this turns, it pulls the eyelid open. And I don't know if I can make it do that without actually driving the motor, but we'll see that happen in a second. So what I've done is I've connected my multimeter, and I'm going to be using it in current measuring mode. So we switch our leads out to measure current, and then I've got the output. This is the port that drives the motor, and what I've done is I've set one wire from that motor. So this is the motor connector. One of those goes directly to the board. The other one travels through my multimeter in current measuring mode. So that means with the power coming from this battery pack, I still have that connected, and the button that's on the front to ring the doorbell still connected, so I'm going to reach around there and press that. I'll put this multimeter into min-max mode, and I'll press the button, and we'll see it's drawing about 0.1 maximum, okay, 0.2, about 0.2 amps or 200 milliamps. So I know that my current draw needs to be roughly that. This is measuring the max, so it probably didn't go any higher than that if this thing is measuring quickly enough. But you can give yourself some leeway there too, just to be safe. So we know we need to be able to supply about 0.2, 0.3, or 200, 300 milliamps to that motor. The other motor is actually drawing less, and that's the one that moves the eyeball side to side, and that's because this one is essentially stalling. It's pulling and stopping in holding, actually. It's pulling and holding in that eyelid open position. And I can just turn that around for fun so you can see that. So again, we'll clear this out. Let me set the range. Put it in min-max and it'll stay on max. Press this, it opened up. And I don't have the speaker connected right now, so it's not, you're not hearing any of the audio out of it, but it does still also do the audio. So that was less that time, and it probably had to do with me flipping this upside down, so it was easier for the motor to pull that stuff. That's my only guess, is that we got an assist from gravity. Could be wrong there, but that's my guess. So next thing I'll do is I'll detach that, and we'll do the sort of easier measurement, and the one I actually did first, which is just what's the voltage it's supplying. So let's look at that same connection there. Let me move some stuff here. So I'm going to disconnect the leads that are going there. I'm going to disconnect the motor entirely. So that motor there plugs into that port. And now I'm going to switch my multimeter into voltage measuring. And I have the leads of my multimeter going into some little DuPont connector wires so that I can plug those in. And you'll either get a negative or a positive on here, depending on what you pick. This one, you might not be able to see. It actually says plus on it for... Bring this up a little higher. This has a little plus sign right next to it, so I know which happens to be plus. It doesn't matter either way. We're just finding out the voltage on this, and it will, in this case, go. It should go positive and negative because the motor heads in one direction and then the other. There's a chance this one only goes in one direction and then just lets go. So it might not go negative. This one does for sure. So let's try them both. So again, I'll set this to min-max, and I'll press the button. So it's trying to turn the motor, pull that eyelid. And we get a max here of 4.4. So like I said, about, oh, you can't see that. Zoom out a little bit again. So 4.5, 4.4 volts, that's what we were getting off of that one. This, I think let me consult my photo. I took a photo last week before I took everything apart so that I'd remember where it goes. And actually, it's down here at the bottom. Yeah, so these are the two motors down at the bottom. So let me switch this out. And this one actually has the same orientation, so the positive is marked on the board on the right. And I will clear this, hit the button. And so you can see this one goes up to 4.5 and then goes down negative 4.5 roughly. And this, so that's the eyeball kind of sweeping back and forth as it turns positive and negative. So there's some kind of a motor driver, like a H-bridge motor driver, that can send positive and negative voltage, which the DC motor is happy with. And this is another clue that it's a DC motor you're dealing with. I don't think you're going to see that with something like a stepper or a servo motor. They're going to get positive voltage and then other methods of controlling them. So if we look at the minimum and maximums, it didn't store them. All right, why not? Let me try that again. So 4.3 max, and then it should drop negative. Yeah, minimum is negative. All right. So those are our clues on that. Then I'm not going to mess with the LED right now. We can guess that it's going to require something like a 2.2 volt, 2.5 volt, something like that. You can even just look up based on the color. You could detach this and do the full current draw if you wanted to as well. And then there's the speaker. And actually, this is one that I need to find out. Just generally, you find somewhere between like 4 and 8 ohm speakers in these things. So it's a safe bet to start with a audio amplifier that can drive that. That can drive 4 or 8 ohm speakers. If someone knows of some of the better ways to figure out what we're dealing with the speaker or with checking the audio signal coming out of it, I'd love to know. I'd like to write that up. In this case, I guessed and it just turned out okay and I didn't ruin anything. But that's another part that you'd want to figure out. So let's see, what I'm going to do next is take a look at how we can drive this. So what I decided to go with, if you look at our requirements, we have 2 motors, we have a switch we want to read, so I want to read pressing that switch. We have a speaker we want to drive with an audio amp, and we have 5 volt roughly motors, and the current draw is actually nothing too strong. So the Adafruit Cricket is a really good candidate for that. There's our Cricket board, and I can drive this from a Feather. There's also versions that you can drive from a Raspberry Pi, from a Microbit, and from a Circuit Playground Express or Circuit Playground Bluefruit. I'm using a Feather RP2040 in this case. And what we want to do here is actually, I'm going to remove some of these and put in these nicer connectors I made. What I want to do is be able to just plug in stuff from the doorbell into the Cricket and then write code on the Feather that will drive those things. So the Cricket takes care of, it has a port here that we can plug in a battery pack, alkaline battery pack, or wall power, depending on how you're using this thing, with a DC, AC-DC converter wall wart. And then I'm using 1 or 2 of these signal inputs here, or in-outs. So I'll use the input to read the button when it gets pressed. We could use one of these outputs to drive the LED in here inside the eyeball. I've got audio output, And by the way, one of the gotchas with audio output on the Cricut that I forgot at first and thought, what's not working here? There's a jumper that you need to close when you're using the audio system on here. So I've closed that little pair of pins on there with a jumper so that I know the audio amplifier is going to work. It's a little Class D amplifier. We'll connect to that. This may or may not be necessary. This is you can place a capacitor across ground and 5 volts to avoid brownouts, even out, smoothen out the voltage on the whole board. And then I've got 2 motor ports that I'm using to drive DC motors. So what I'll do is I'll take these nice little guys here, we might as well use these and connect those up. So I used silicon wire and connected and soldered to the little loose guys, but we sell these pigtails, essentially, I think a 5-pack in the store, so they might be a better way to go. So I'm using silicon wire, which one of my favorite things is you can just trim the insulation with your fingernail. And then we'll plug in to our Cricut board. Let me zoom in here to my maximum zoom and get you some focus. So for this, again, with these, you can change in code which is positive and which is negative, so it actually doesn't matter too much which way you go for the DC motors. This stranded wire is a good choice for these terminal blocks. In fact, better than what I had in there before, which was little DuPont connector pins. So I will connect that up. And so this is the eyeball side-to-side motor. And I'm plugging that into motor 1. These are marked on the silk screen as motor 1 and motor 2. So motor 1 will be to drive the eyeball left and right. And that'll just connect like so. Well, when we get all of these connected up. So next we have the eyelid. And I don't need that anymore. This one is the orange and gray. I was able to match the colors pretty well of what's in there, which helps you to not get so confused. I think that's how I had that. I hope so, because this is the one I don't want to get wrong, because it will yank the thing open when it's already open if I get it wrong. But it is actually a pretty sturdy mechanism. I didn't break anything so far, so let's see. One thing you can do is move things just a little bit lower power and not for very long at first to see which direction motors are going. You can also loosen up the motor mounts so that they wiggle in there instead of binding. Then audio, so the speaker is this little green wire connected here. And it's nicely mounted into the plastic here, and it uses this whole cavity as a resonator, so you don't want to mess with that. If you can leave that connected and use the speaker that they used, that'll work best. So for green wire, that's going to go either of those. Polarity doesn't matter in this case. Into the little audio out. I'm going to twist this a little bit. This is the one trick with stranded wire and screw terminals, is you don't want like one little bitty thread to bridge their connections, and it happens sometimes. But you also don't really want to solder, like tin those, because they don't get grabbed as neatly by the screw terminal. All right, so, and then lastly, I've got my switch connection already there. So let's start hooking some things up. I can clear out my space here a little bit. And Zoom out again. Okay, so we'll do, I'm not going to use this battery power for now. I may, we'll see. So this is going to be the speaker, and now it connects right in like that. We can do the switch, which I have plugged into signal 1 and ground here. Do the motor for the eyeball, and then motor for the lid. And I think I got those right. All right. So why don't we give it a shot right here, and then we'll go and look at the code. But I've got this doing some stuff already. Not quite everything, but I'm going to give this power. And I happen to have a really beefy 5-volt wall wart switching power supply, actually. Okay, so with the Cricut, if you're not familiar with these, the power is supplied by the Cricut board. You can program the feather here over USB-C, but you're not using that for powering the whole thing. And then there's also a little micro USB-B connector for flashing the firmware of the Seesaw chip on the Cricut, so you don't need to touch that most of the time. Should just be fine. Maybe flash it once. So now I'm not really doing anything on the board physically. I'm actually going to use this button here. When I press that, that should be read over signal 1 on here, and then it should tell our motors and speaker to do stuff. So let's see what happens.
What? You want some treats?
Okay, so I got the lid backwards, so it opened at the end. Let's turn this off, and I will switch those around. Yeah, so that motor only goes one direction during the animation. The eyeball goes side to side, but the lid only pulls open. So what I'm going to do, just for safety of the device, is I'm going to unplug this connector so that it doesn't try to open itself a second time when it starts up, and then I'll plug it in once it's running. Power that up, press the button. Okay, now I can close that. Here you can see it scooted when it closes off. Okay, so now it should work. So what you're going to hear now is a different voice track, a different audio file. It'll do the ding dong, and then it's going to do a different voice track.
Did you know I was afraid of the dark?
Do another one.
Don't look now, but there's something behind you.
That guy loves to scream. So let's take a look now at the code that I've got running on there so far, and maybe we can mess around with that a little bit. Let's see, I might have to bring this power supply over there. You know, in fact, let's just look at the code first, and then we'll see if we want to mess around with it. Adam Bryant says, use an analog meter to measure the speaker. Oh, that's an interesting idea. All right, so let's jump over to the code. We can leave that there. And yeah, it does sound a bit like a Wilhelm scream. That's a good point. Let's see. That'll work. Okay. So let me grab the code here. Okay, so here's what I've got running on there. I'm importing the Cricut library. It's a little cut off there. Importing the Adafruit Cricut library as Cricut, and that actually takes care of a whole bunch of stuff at a high level. Other than the audio. Audio is handled on the Feather, and it's just using the amplifier circuit on the Cricut. But everything else is handled essentially by the Seesaw chip on the Cricut. And these are the commands we're using. So for example, for the button, we're just saying button is a variable for Cricut signal 1. And so signal 1 is that part of that little block of 6 input-output pins that we have there. Then I'm setting that pin mode to be an input pull-up. Audio I'm setting up as a PWM audio on the, this is a Feather RP2040, so it does PWM, doesn't have a DAC, and it does that over A0. And then I'm setting up a set of audio MP3 files as this little list called ring 1, 2, 3, 4, and 5. I should probably give them a different name because these aren't the rings. The ring is this one here called ring 0. These are actually the voice files. And I start off with the first one in this list. So I have a variable called current audio file, and that starts off as this one here, the first one. Then I set up the MP3 decoder. So this is using audio MP3, which is built into CircuitPython. MP3 decoder, open the ring 00 MP3 file. That's just the ding-dong part. Then I'm setting up my two motors. So I called the motor I and motor lid, and those are the motor 1, DC motor 1 and DC motor 2 outputs of the Cricut. Then I've created a function here for opening the lid, and this is mostly through trial and error. I just figured out that setting the throttle to full speed, it's actually not backwards, full speed ahead is the direction I needed to send it. And remember before when I ended up switching the leads, we could have also just switched it in code if we wanted to. So I set that for just a quarter of a second. So time sleep 0.25 is enough to get it open. And then I set the throttle to 0, which is essentially like stalling the motor. It holds it open. I believe the stop, it might be the stop command or idle. There's something that kind of just puts it into neutral. But this, I think, is holding it there so that it can fight the springs that would pull it closed. And then close lid is my function for closing it. And this is just for clarity. You could, of course, do this other ways, like just have one lid function that you give an argument to 0 or 1, that sort of thing. But for clarity, I made two functions. And then that's all the setup that's necessary. And here's what happens in my main loop. And again, I've kept it pretty verbose for clarity. So first thing is we check the button. If the button goes low, that means we've pressed it. So that's why it says if not SS, which is for Seesaw, digital read button. It'll print that it's been pressed. It will set the decoder to be the ring, and then I play the decoder file. Then I open the lid after it plays that ding-dong, so that's why it says while audio playing pass. So this means we don't have to do something like know how long it is and set that in as a time. Instead, just say while audio is playing, what do we do inside the loop? We just pass, then that means we're just going to hang out here until that audio file is done playing. So it goes ding-dong, then we run the open lid function. And then I'm changing what this decoder value is. And there may be a better way to do this. I think if I looked at some of our MP3 player code, like stuff that Jepler did, there may be a better way. But the way I decided to do it, first way I tried it that actually worked is this. So I just decoder, change what file it's pointing at, which is that audio files list, and whatever the current audio file is. So it starts out as 0, so it's the first item in that list. And then I play. This time, I don't want to wait for the audio file to end. I, in fact, want to do all of the looking around. So while it's playing, I'm essentially looping this over and over again. So however long that audio file is, it's going to drive for half a second in one direction at almost half speed, 0.6 speed throttle. Then it's going to pause there for a second. Then it's going to go for 3/4 of a second, the rest of that direction, then it's going to switch and back and forth. So it's this little kind of look, stop, look, stop, look, stop that's ideally going to look like it's picking out different trick-or-treaters in your front yard. It'll loop through that cycle, so I don't want that cycle to be too long because I don't want it to go on forever and ever after the audio clip is done. And you could make this a shorter cycle, and then it would stop pretty much right when the audio ends. But when the audio ends, it's done doing that, and it does this, throttle 0. So I stop that motor, and then I run the close lid, and then I increment the audio playback file so that the next time we press the button, it will go to the next one in the list. And I'm using modulo of the length of the list -1 so that we loop back around over and over. So every time we press it, we'll just run through those 5 audio cycles. And so that is the basics of how this works. Some of the setup for it was just finding the audio files. You could use anything you want, right? Any MP3 file that you can play back. The ones that they recorded for these devices sound particularly good because they're in sort of a range that works really well for that speaker, sort of the sonic range that it's in works really well. I tried playing a little song that I'd written, and it sounded terrible because it needed a lot more bass than that speaker could give. But that screaming guy and all his creepy sayings works really well on there. And let's see. So yeah, I think that's probably a good place to stop with that. You can imagine it's free to you to code up whatever you want it to do. I haven't got the LED hooked up yet, only because that's the only thing on there that wasn't on a connector, so I will have to cut or splice the wiring on that to use that, and then still be able to put the thing back together. I was hoping for a totally non-destructive hack, but I will have to cut the wires for the LED or desolder them to be able to use that. So let's just have one more look at this guy before we wrap up. We'll hear a different phrase this time because I haven't turned it off, so it's ready to cycle to the next one.
Let me take a look at you. Closer, please. A little closer.
Also, one thing I did was I have, let's see, can I put me in the corner? There I am. I have not opened the eyeball all the way. It'll actually open that far if we drove that motor for a little longer. So I decided it looked kind of neat to have it creepily part way open. So again, that's the kind of choice you get when you're driving it with your own microcontroller. Other reasons you would do this is we can have wireless, right? If we used let's say ESP32S2, we could connect this to the internet over Wi-Fi. If we used a NRF52840 based feather, we could do Bluetooth stuff. Trigger things off of your phone. Also, you can add a lot of other sensors. So you could maybe add a light sensor or a distance sensor to the project if you want. And the other thing I'm thinking is it may be plausible. Let me unplug this for a second to turn it off. It may be plausible to fit this in here either as is, we may have clearance, or more likely extend the back. So make a longer back or 3D print your own back on there if you wanted to, or you could sort of neatly wrap all those wires through a little hole in this, maybe come through the battery port and have this extended in somewhere else. So you've got options there. Again, not to disrespect the designers of this, because it's fantastic. They've done what they've done for the low cost of $15 for this thing, mass produced. It does what it does. It does it really well, but we get to kind of explore and hack and modify if we want to. And in this case, the chip on here is just an epoxy covered blob, so there's no reverse engineering it or taking over and putting different audio on there. You're not going to be able to do that unless you're super uber hacker. But for me, I just want to take over these, and they made it really easy with these connectors. So I get to mostly take advantage of the physical form, layout, enclosure, and mechatronics that they've designed, but with my own audio in this case and my own animations.
What? You want some treats?
You can imagine I've gotten really tired of that guy screaming. Oh, by the way, one other thing. Let me go back over there. The original was louder than this. And another thing to know about the Cricket is that it has a little potentiometer that you can turn with a screwdriver. This is a tiny little trimmer pot that you can adjust the volume with. So check this out. Let me get set up for it, and then I'll...
Did you know I was afraid of the
So we can get really loud or much quieter while we're testing, which is nice. Unbelievably loud. Sorry about that. I don't know if I'll have a ringing in my ears for the rest of the day based on that one. So thanks for coming by and hanging out. Lots of fun to play around with these, and hopefully it inspires you to go and look through your bin of Halloween stuff or holiday stuff. These Gemmy people make all sorts of Christmas stuff, Santa things, reindeer. I don't know what other, they definitely do Halloween and holiday, Christmas, winter holiday kind of stuff, but there's probably more. I think they did SpongeBob stuff. That would be kind of a fun one to hack. So. Especially if you can get these on clearance. I see people finding these for a couple bucks on clearance, mostly because the batteries have leaked out at the store over time. So get them cheap and hack at them. Have a lot of fun. All right, check in with our Discord before I go. Where'd my Discord go? Have I lost it? There you are. Hey, Discord. Thanks. Yeah, thanks, Jim Hendrickson, Eddie Calloway, Foamy Guy. Foamy Guy, volume knob for testing is so nice. Worked on gadgets like that before, and hearing it play a million times so your working gets old. Oh, one other funny story I want to share. While I was in process of this, I had unplugged a motor and I plugged it back in to test it into the main board, the original board. And I had the speaker unplugged, but when I hit play, I was hearing sound. I was like, that's weird. Do they have like a tiny speaker built onto the board or something? No. It turns out I plugged the DC motor into the speaker output, and the DC motor was acting as a speaker, which is, I'm sure makes a lot of sense to some electrical engineers out there, but for me, I was like, whoa, why is the DC motor a speaker? But it is. Everything's a speaker, and every speaker is actually a microphone. So, transducers, man. How about it? Let's see, other thoughts and questions. Marie Meyer asks, do you have a link for that site? So they're called Gemmy, Jemmy. They may or may not even have their own site. I think they just manufacture stuff and sell it to retailers. So the site I was looking at was a fan site, fandom.com, so gemmy.fandom.com. And this one just happens to be about their eyeball doorbells, but I think if you hit the Gemmy Industries wiki, you'll see they're #1 for Halloween and Christmas. These are some of the kinds of things. Novelties, yeah, they did Billy Bass. I don't know if they were the inventors of it, but I see their name around Billy Bass. Probably they are, or the manufacturers originally. And so, yeah, it's tons of stuff, large-scale things, werewolves, and so on. Probably Paint Your Dragon, our own Phil Burgess has knowledge of this. See, Grover says DC motors do that. The cheaper the motor, the louder the sound. Yeah, it was definitely discernible. It sounded like a tiny speaker. Freaked me out. All right. I think that's going to do it for today. So thanks, everyone, for stopping by, and I'll see you on Tuesday for another John Parks product pick of the week. Tune in tomorrow for Scott's Deep Dive, where he continues to put CircuitPython onto the bare metal of Raspberry Pis and upsets the natural order of the universe in doing so, but very exciting. Imagine the power we'll have. I think that'll do it. So thanks, everyone. See you next week.